Good evening, minions. Your captain is here. Welcome, welcome, welcome. Good evening, all the VE enthusiasts. Hello, VK, Yalini, Sam, and all others who are here. Hello, hello, hello. I hope you can hear me loud and clear. This is Shreyas here, your captain, your master teacher for physics at Vedantu, and I'm going live. And today there is a very important session and I'll talk about it in detail. But before that, let me quickly introduce myself. So all those members who are very new out here, well, first of all, interact with other IITians and other VE enthusiasts out here and say hello, introduce yourself, make new friends, and yes, do not forget to hit the subscribe button because only then you can become a member of our family. Hello, good evening, Karthik. Good evening, everyone. So I have been teaching for quite some time out here, and I have not only taught on online and on YouTube, but also in many offline coaching institutes, the big names that you can think of. And many of my students have not only cracked IIT, but in fact, they have aced IIT with excellent ranks. Sometimes they have also got 2-digit All India ranks in JEE Mains and JEE Advanced. So I'm here to make sure that I spread this joy of learning to every one of you who wants to learn in English, because there are hardly any English channels out there in India, especially on YouTube. So welcome aboard. Hello Sohib, Ankit, Aditya. Welcome Science Priya. Hello, I'm very good Sohib. Great to see everyone out here. And by the way, before we begin, do not forget to hit the subscribe button because that's how you become the member of our family free of cost. And now that you have already subscribed, do not forget to smash that like button out here because everything that we give you out here is absolutely free of cost. The only cost that you have is love and support to all of us. That's it. Hello, Viswa. Good evening. Now, this week, like I was telling you guys, so yesterday we had NCERT underline plus previous year questions on communication systems and semiconductors. In case you have missed that lecture, watch it in the past sessions and also in the playlist which has been created. So that's something which you can check. Now today and tomorrow we are going to have most expected, most peculiar kind of questions which can be asked, high probability questions for the upcoming JEE Mains. Today is 12th standard questions, tomorrow is 11th standard questions. So all the 11th standard students, guys, remember, if you are thinking that we have forgotten you, no, please understand we have kept a special session for you guys as well. So this session can be attended both by 11th as well as 12th. So that's the speciality of this. Remember, for 12th standard students, right, even the 11th standard portions is equally important because it carries 50% weightage almost. So do not forget to attend both of these sessions tomorrow at 7 o'clock. In fact, all these lectures are at 7 o'clock. Okay. Then marathon session, formula revision with concept application for 12th and 11th. So one is 11th actually and the other one is 12th. So I think I should edit it right away so that there is no miscommunication. All right. So one is 11th standard and the other one is 12th standard. Okay, cool. So that's something you can keep in mind. Okay. And on Saturday, again, very important questions for JEE Mains. Very high probability questions for JEE Mains that's on Saturday. Keep this in mind. All right. Now, before we proceed ahead, hello Shreya, hello Omkar, welcome. Hi Aishwarya, nice to see all of you. Before I proceed ahead, let me also remind all the JEE aspirants out here. See, after JEE Mains, the next obvious step is JEE Advanced, right? So, all those of you are wondering what to do and how to study for JEE Advanced, what if I want to get a really great rank? Is there something that Vedantu will give me? Yes. We have planned Eklavya batch, and that Eklavya batch is very, very important for your next preparation, next step for JEE Advanced. All right. And we are going to make sure that this batch is going to be really, really amazing because last time when the Eklavya batch, happened, in spite of that pandemic, we produced more than 500 results in JEE Advanced. Just from Vedantu. That's very interesting to know. More than 500 students got selected in JEE Advanced. I'm not talking about mains. So this is a very important milestone for all of you. Remember, the batches are starting on 8th March. That's one of the batches. Then the next batch is on 19th March, then 1st May and 29th May. So it's better that you start enrolling in this batch as soon as possible. The details are in the description box as well as in the Telegram group, whose link is also there in the description box. So these are live sessions with lots of thousands of questions, with assignment booklets, collection of really good problems for JEE Advanced, online tests along with the discussions, and best part guys, everything is for free. Not even 1 penny will be charged from all of you. So that is very interesting. Yes, Karthik, semiconductors was done yesterday. Yes. So, well, Kishore, point noted. Don't worry. We will do it after the first attempt. Don't worry, Kishore. All right. Yes, the concept revision, live sessions, problem solving, advanced level problem concepts, all these things will be done in this course, and that is free of cost. That's very important. All right. So keep this in mind, and do not forget to check out our Telegram group, because all the details will be also posted over there. All right. So let's begin with our first question for today. So get ready guys. I hope you have your pens and papers out, because you need to keep solving along with me, and make sure you interact with the other students, help other students in case they find something difficult, or maybe they are asking some obvious question which you know the answers, and welcome all the new members to this family. And also do not forget, if somebody tries to spam, you know what to do. Yes, make sure that you keep the virus away. All right, in this circuit, we need to figure out what is the instantaneous current, and let's see how. Don't worry, Tirth, even if you do not get selected in the Eklavya batch, we are there for you. We are also going to make sure that the advanced preparation will happen on this channel as well. Don't worry about it, Tirth. Okay, so because this is a JEE channel, right, at the end of the day. Okay, so let's see how to solve this. So first of all, what I feel is, since this is a AC circuit, all right, and we have to find the current flowing in this circuit. So what I feel is, let's try to figure out what is the phase difference, because in AC circuits the main problem happens with the phase. Second thing, we'll also figure out the current in a bit, but before that, let's calculate what is omega, what is L, etc. Omega is, you can check it out, it is 100. Omega is 100. So the reactance for the inductor, so the inductive reactance, recollect the formula, it is omega L. So it will be nothing but 100 into 1, which is 100 ohms. The resistance is itself 100 ohms. So if you think about the triangle for resistance, remember the resistance in that phasor diagram, that vector diagram that you draw, is always horizontal. All right, the resistance is always horizontal. Inductance is always in the vertically upward direction, like this. So this is where XL is always. There is no capacitance in this case, so that's why forget about it. So the resultant of both of them, is Z. Now, isn't it obvious that if this is 100, this is 100, shouldn't Z be obviously 100 root 2 ohms? Z is equal to 100 root 2 ohms. Yes. Abhishek, my blessings are always with you and all the minions and all the V enthusiasts out here. Hello Mini, hello, welcome, welcome. Yes, Alvin, don't worry, we'll see whether it is B or not. Hold on. Now, I just want to get to the answer, and I'll also tell you the other way of solving it. Hold on. This angle, shouldn't it be 45 degrees, which is nothing but pi by 4 radians. And the last step in this problem is, see, this is the voltage, 200. So what will be the current? The current amplitude will be the voltage divided by Z. Just like current is voltage by resistance, so the total current will be total voltage divided by total resistance, which is called as Z or impedance. So the total voltage is 200. Z, I just figured it out. It was 100 root 2. 200 by 100 is 2. 2 by root 2 is root 2. So it will just become root 2. Hence, the current value will be, outside you will have root of 2 and you will have sine of. Now, remember guys, in a LCR circuit, the voltage, all right, and the current will always form an angle. That's very important. The current is always shown horizontally. The voltage is always shown with some phase over here, and the phasors rotate like this. I hope you remember this phasor diagram. So think about it. Who is ahead of whom? Is voltage ahead of current, or is current ahead of voltage? Obviously, voltage is ahead of current. You can see that in this phasor diagram. Hello Saurabh, welcome, join in. That means the current's phase must be behind by pi by 4. Hence, that's why I'm going to write it as omega t minus pi by 4. Because the voltage had something, and that omega over here actually is 100. So sine of 100t minus pi by 4. So that's how this equation comes. Alright, I hope this is clear. That's how these things work. Okay, let's remove this. Alright, so all of this has been explained neatly, and this is how you get the answer. Please keep in mind, in the original options, both the things were there, plus pi by 4 and minus pi by 4. Alright, so you need to be really careful about it. In fact, if you have to do this question in the examination, you can do it by elimination. See, if it is inductive circuit, the voltage will be ahead of the current if it's inductive, because there is only inductor. So the current should be behind the voltage. So only those options which has a minus should be taken. Do you agree with this? Only those options which has a minus phase should be taken. So this option gets eliminated. But the inner part, which is 100, should not change. So basically, either it will be this or this, but it can't be this. This 200 is not possible. This plus is also not possible. So only the two options which remain are this. So, if you have to narrow it down, you can narrow it down to these two options and solve. That's also clear. Okay, so SL we took minus pi by 4 because, think about it, it's an inductive circuit. So the voltage will be here, current will be here. The phasor diagram looks like this. This is pi by 4. So who is behind? Current. That's why current had minus pi by 4. Yes. Cool? I hope that's clear. Okay. Is that clear, SL? Let's get going. Now, how about this circuit? Alright, very good. So guys, that's the specialty of this channel. Please interact with me, help each other out. This is a very special channel for all the people who want to prepare for the JEE Mains and Advanced examination, including BITSAT, CET and other examinations. Please keep that in mind. And we are going to discuss every question in detail. It's not like I'm going to do everything over the air. It's going to happen in detail. Alright, so coming back now to this problem, what is the output of this circuit? Let's do this. Hello Princey, good evening. So is it A bar, A plus B or AB? Now this kind of logic gate circuit has to be solved using something called as the truth table, and it is very simple. See, these are the two inputs, these are the logic gates, something like operators, and don't worry, I'm not going to solve it immediately or give you the answer. You can keep solving simultaneously. So the thing is, we need to figure out what Y will be. Okay, now think. What we need to do is think about all the possibilities A and B can have. All the possibilities A and B can have. All the possibilities are 0, 0, 0, 1, 1, 0, 1, 1. 1 is like true, 0 is like false. You would have done this kind of truth tables in maths also. Maybe even in 10th standard or in computer science. This is exactly like a truth table. Now think about it. Sam, my motivation is always with you, and keep solving problems with me. You will automatically feel motivated once you get that confidence. Alright. Now think about it. A and B both go inside this operator, which is OR. OR means this or that. If either one of them is true, the net output is true. Either one of them. This is 0, this is 0. 0 or 0 is 0. Keep this in mind. 0 or 1, one of them is true. It is true. 1 or 0, one of them is true. It is true. Both of them are true. Very good. Then also it is true. Yes. Giant, don't spam out here. Please keep this in mind. You can post it once, but don't post it 100 times or else you might get blocked from the admin. Be careful. Okay. Now, This is the output over here. Now this point and this point, which is A, all right, that is the input for the next operator, which is AND. Now think about it. This and this, this and this, what will happen? 0 and 0 is 0. Keep this in mind. Both should be true, only then it is true. That is the meaning of AND operator, correct. Now 0 and 1 is 0 because one of them is 0. Both should be true, only then it is true. 1 and 1, 1. 1 and 1, 1. Now you can see this entire table is very similar to A table. So hence the final answer is A. Yes, very good, very good, very good SL, very good Science Priya. Yes, Sam, it's like a verification table. Yes, Yalini, very good. Very good, very good. I hope you guys understood how this has to be done. Shall we go ahead about this? So the final answer is actually A. You can see that. Very good. So use truth table. Yes, very good. So Gigantic, I know you said it first, but please make sure that you don't spam. Okay, let's do the next question coming up. Now there is a point charge and that is placed at a distance of r from the center of a conducting shell. Okay, we'll imagine it in a bit. Hold on. For now, just visualize. There is a point charge placed at some distance from the center of a conducting shell. Inner radius of the shell is 2r. Outer radius of the shell is 3r. Find the potential at the center of the shell. Find the potential at the center of the shell. The answers are in epsilon, q and r. Don't worry which option is correct or wrong. Just think about the final answer. If you want, you can solve it with me or you can solve it separately and you can check the final answer. It's up to you. All right, let's see how to solve this. First, let's visualize it. There is a charge at a distance r from the center. Now, because of this positive charge, guess what is going to happen, guys? Because of this positive charge plus q over here, you are going to see induced charges on the inner surface. So you're going to see induced charges over here, something like this. This will be the induced charges, and that induced charge is going to be minus q. Yes, that induced charge is going to be minus q. Now, because of that induced negative charge, see, where will these negative charges come from? It would have to come from outside. So to conserve the charge, what will happen? There will be a plus q charge. Yes, there will be a plus q charge which will be equally created on the outer surface. I hope this makes sense. So this is the final charge configuration of that system. Now the question is, what is the potential at the center? What is the potential at the center? Now the potential at the center will be because of all the three charges, the actual as well as the induced charge. See, this actual charge q is at a distance r. So basically because of that charge q plus because of that charge minus q, which is there on the inner shell. You can see that it is there on the inner shell. All right. Plus the charge plus q. Where is it? It's there on the outer surface of that shell. It is there on that outer surface. You can see that over there. Now just use formulas. Use formulas. Hi Jitesh, don't worry, we'll see whether it is C or not. Hi P Nikhil, welcome. Hi Dia. All right. So because of this charge, it's going to be K Q divided by R, guys. Divided by R. All right. Then because of the negative charges, what will happen? It will be K minus Q divided by, what is the radius of the shell? The radius of the shell is 2r. So kq divided by 2r. That's the formula. K into charge into divided by radius of the shell. So that's the formula for potential. Plus k into q again divided by, this time it will be 3 times of r, because these positive charges are at the distance of 3r from the shell. That's it. Once you get it, just simplify. See, you will get kq by r as common, and what else will you have? 1 minus 1 by 2 plus 1 by 3. So k is nothing but 1 upon 4 pi epsilon naught q divided by r. Now take the LCM, guys. So the LCM is 6. So this will become 6 minus 3 plus 2. So this thing will eventually become 6 minus 3, 3, 3 plus 2, 5. So 5 divided by 6. So 5 by 6 q by r into 1 by 4 pi epsilon naught. Excellent, excellent, very good SL, very good, very good, very good. Yeah, very good Yalini, yes, time pass, very good, very good. So that's the answer. That's how you do it, and you can see that 5 by 6 q by r 1 upon 4 pi epsilon naught. Yes, that's what you can see. Now let me also tell you, hi, good evening Dharma. We have a very special announcement before we go to the next problem. The special announcement is a lot of students who said that we want to enroll for the test series, but there was no option for test series. We have created a special test series for JEE Mains just for you. And this test series has 20 test series with live discussions, and these tests have been prepared by all of us to make sure, number one, there is no errors. Number two, we are making sure that these tests cover all the concepts right from 11th to 12th standard, and there are different kinds of tests, part syllabus, full syllabus, and this is before your February attempt and after your February attempt for your second attempt of JEE Mains as well. So all these tests are very important so that you realize your mistakes. Just like we solve problems and discuss over here, over there you have a class teacher inside the class who is dedicated for a group of students who will be simultaneously solving all your doubts in the class while these test discussions are going to happen. So these are live classes, these are really good questions, covers entire syllabus, also doubt discussion within the class, 10 tests before February attempt and 10 tests before the March attempt. All of this at a price of actually 2,500 rupees. But because you are attending my class, the course will be given to you, the crash test series will be given to you only for 1,999 rupees. That's really nothing. If you look at it, 20 tests for 2,000 rupees, that's hardly anything, guys. Come on, hardly you are paying 100 rupees or less, but for one test. That's really, really cool. I think you should definitely go ahead and join it. Right away, use the coupon code SHCC if you are a JEE aspiring student, especially 12th or dropper. The link is in the description box. Use that link, enroll now only, so that you can practice really well before your next attempt. It's hardly 100 rupees per test. All right, cool. Let's go to the next question. Yes, let's go to the next question. Okay, very good Omkar, very good. All right. Okay, so how about the next question? Is NCERT enough for 70% JEE preparation? No, Sam, NCERT is not enough. No, definitely not. Okay, very good. Chalo, let's do this. Let's do this. And how about this question? I think it's based on Kirchhoff's voltage law. Okay, so voltage difference between A and B is given, and the question is find the current passing through the 2 ohm resistor. Now there is no other way apart from Kirchhoff's voltage law, believe me. Let's do this. So first thing that you should do is assume currents. So say for example, from here, let's say the current comes like this. Let's say it is I, and let's say it gets split into two parts. One current over here, which is I1. So if I1 goes there, so over here in this branch, the current which will be going will be I minus I1, and it will again combine back, and you will have a current of I. The next thing that is given, the voltage between A and B is 16 volts. So if I assume B to be 0 volts, if I assume the B's voltage to be 0 volts, A's voltage will be 16 volts. Okay, so that's the potential difference between them. Okay, let's solve this now. I'll just give you the two equations and let's see how to do that. The first thing, to apply Kirchhoff's law, remember, you need not come back to the same point. Yes, there is an incomplete Kirchhoff's law also. Basically, you start from a point and end at a point, and I'll show you how to apply it. For example, you start from point A and go to point B like this. For example, you go like this. So how will it look like? So from A to B, if you apply Kirchhoff's voltage law, this is how it's going to look like. You first tell me what is the potential of point A, and then whatever I encounter ahead, add those potentials or subtract those potentials accordingly. If the potential goes up, add it. If it goes down, subtract it. And dropping, rising ahead, you will eventually reach B. So the sum of all these potential differences plus the A's potential will give me the final potential at point B. Okay, so point A's potential plus the drop and the rises which happen will give me the final potential at point B. That's all. So from A, the first thing is the resistor. So current is going like this, and I am also going like this. So current will make sure that the potential drops. So the drop will be minus I into 4. Okay, that's the first term. Now this is a battery. I'm going from positive to the negative terminal. So again there is a drop of minus 9 volts. Next, there is a resistor. You can see that, and I'm going in the direction of current. So the voltage will again drop by how much? Minus I1 into 1. Okay. Then next one, there is a battery. I'm going from negative to positive, so it will be plus, and by how much? 3 volts. Okay. And the last one, I'm going through a resistor, the voltage will drop, so it will be minus I into 4 should be equal to the final potential at point B. And how much is it? It is 0. So now you can see, you can solve this. What is the potential at point A? It is 16. I just told you. Now 4I and 4I is going to make it minus 8I. You can see that 4I and 4I is going to make it minus 8I. And you have minus 9 plus 3, which will make it minus 6. And you have minus I1 over here, and that should be equal to 0. Therefore, you will have 16 minus 6 is 10, is nothing but equal to, yes, isn't not equal to 8I plus I1. Just check this out. 8I plus I1. Just check this out, guys, if you're getting it. Okay. Now, the next thing that we'll do is, we'll go like this in this loop. So we'll go like this in this loop. So see what will happen. Okay. So let's start from here and see what happens. I'll start from here and I will come back to the same point. From here to here, I just encounter this resistance, 2 ohm resistance. So again, if I apply KVL, let's see what do I get. Minus, because the voltage will drop in that resistor, minus this current into resistance. So minus I minus I1 into 2. Then from here to here, you can see I'm going opposite to the current. Be careful. So it will be plus. Yes, the voltage will rise because I'm going opposite to the current. So it will be I1 into 1. And this battery, I'm going from minus to plus. So again, plus 9, that is equal to 0. So just do that. So you'll have minus 2I, minus minus plus. So 2I1 plus I1 plus 9 is equal to 0. So keep that 9 on one side. So you will have 9 is equal to 2I will go there. So it will become plus 2I. 2I1 plus I1, 3I1. So on that side, minus 3I1. So you have your two equations. Like you can see, solve these two equations and you will get the answer. Is that clear? Yes, this is how you solve it. So the main idea is to use Kirchhoff's law, and these kind of questions do come in the exam. That's why I'm giving you these kind of questions, because these are highly probable kind of questions. Keep this in mind. Now when you solve this, the answers that I have got is something like this. Okay, so what I have got, I think I1, I have got it as, all right, I have got I1 as minus 2. I've got I1 as minus 2 amperes, and I have got I as 3.5 amperes. 3.5 amperes. This is what, sorry, my bad. I have got I as 1.5 amperes, sorry, 1.5 amperes. So I have got it as 1.5 amperes, and this I have got it as minus 2 amperes. So once I get this, I can easily find how much is this current. So this current will be I minus I1. So it will be 1.5 minus I1, which is minus 2. So that will come out to be 3.5 amperes. That's the final answer. Yes, that's what I'll get. Cool. So after solving that, shall we go ahead? Shall we go ahead? Okay. Is that clear, everyone? All the minions out here? I hope this is clear. Cool. Shall we go ahead? Yeah. Okay, let's go to the next question. Very interesting question based on photoelectric effect. The radiation of wavelength lambda is falling on a photocell. So photoelectric effect question. The fastest electron is having speed v. Now if you change the wavelength to 3 lambda by 4, the speed of the fastest photoelectron will be more than, less than, equal to, so many options are there. Let's try and do this. All right, very good, Sam, and time pass, Science Priya, Princey, very good. So what do we need to do? Okay, now initially, all right, initially, can I say that whatever photon's energy will be there, hc by lambda, will go in two things. One is the work function and the next one is kinetic energy, which is half mv square, because this was the maximum speed, which was v, so I'm using it as kinetic energy, half mv square. Now finally, all right, the new one has a different wavelength, and that is 3 lambda by 4. So when you use that, the work function is the same, but the speed will be different. So I'll put it as half m v1 square. Now what I'm going to do is, I'm going to put this phi, oops, sorry, my bad. I'm going to put this hc by lambda over here. I'm just going to put it over there and see what happens. So 4 by 3, instead of hc by lambda, I will put this entire expression, which will be phi plus half m v square is equal to phi plus half m v1 square. Is that right? Now just simplify this. You'll get 4 by 3 phi plus 4 by 3 of half m v square. I'll keep it as it is equal to, I can take that phi also on other side. So minus phi is equal to half m v1 square. Now the next step will be 4 phi by 3 minus phi is just phi by 3. So phi by 3 plus 4/3 of half m v square is equal to half m v1 square, guys. This is what I'll get. Now if this term plus something is this term, then obviously this term must be smaller than this term. So I hope you agree that 4 by 3rd of half m v square is smaller than this term over here, which is half m v1 square, because the smaller term needs to be added to this number to get to the RHS. Now just cancel, yes, just cancel half m both sides. So what will you get? 4/3 v square is less than v1 square. So isn't v1 more than v root 4 by 3? That's the answer. Pure mathematics inequalities which you have learned in maths has come to use over here. That's it. Very good, Dar, Ankit. Hello, Ramlingam, Kishore. Hello, Dar, Subzar. Welcome all the new enthusiasts here. Do not forget, you can become a member of our family for free by hitting the subscribe button out there. And do not forget to keep watching the video, because today we are doing most expected questions in the upcoming examination. Very good, Yalini, very good, Harsha, very good, Princey. How sigma gets cancelled? Where is sigma? No, where is sigma? This is phi. Phi did not get cancelled. I just said if something plus phi by 3 is something else, then that something should obviously be smaller than this number, because you need to add something else to get to this number. That's all I said. Yes, very good, Sam. Okay, I hope, Rohit, that is clear. Hello, Kishore. Welcome, Ramlingam. Yes, so that's the answer. You can see more than the square root of that. Correct. Yes. Cool. Let's get going to the next question. Now, a lot of people thought this question is easy and they made a simple or very casual silly mistake. I'll show you what that is. The resistance of the following circuit between A and B is given by, let's do this, 3 by 2, 2, 4 or 8. 3 by 2, 2, 4 or 8 ohms. That's the question. Between these 2 points, what is the resistance? Oops, I didn't want to show you the answer, my bad. Okay, let's do this. Okay, so My bad. Okay, so first of all, you should understand that this resistor is useless. Do you see why? Because this is a balanced Wheatstone circuit. So this resistor is useless. So it's just like these two resistors are in series. They are in series. And what is the value of that resistance? 2 plus 2, which is 4 ohms. Similarly, this and this two resistors are in series. 2 and 2 will also give you 4 ohms. I hope this is clear. Now, I hope you also see this 4 ohm and this 4 ohm are in parallel with each other. Do you see that? And if you do not, think about it. There is one resistor of 4 ohm here and there is one resistor of 4 ohm here. So they are both parallel. That means I can combine them into one single resistor of how many ohms? 2 ohms. So this together is just 2 ohms. If that is clear, no problem, Hatewali. Watch the remaining questions because all important questions are going to be discussed today, which will help you for the next JEE exam. And even if you are 11th standard student, you should attend it. Don't worry. Next up is these resistors here, this resistor here. Okay, so you have 2 ohms here, 2 ohms here, and 2 ohms here. These are the points A and B. Now think about it. These three resistors, aren't they in series? Oops, my bad. Yes, this two, and this two are in series. So if they are in series, what should be the resistance? 6 ohms. Now don't you see there is a 6 ohm resistor in parallel with a 2 ohm resistor between the 2 points A and B. So what should be the resistance between A and B? Shouldn't it be R1, R2 divided by R1 plus R2? 6 2s are 12. 2 plus 6, 8. 12 by 8, which is 3 by 2. Yes, so that is option A. Yes, got it? So a lot of people forgot this 2 ohm resistor. Yes, that is a main silly mistake which people did. They just calculated the top part and they thought it was 6 ohms or something, or some mistake they made. So be careful. They didn't understand where we are going wrong. So be careful. You have to find the resistance between these 2 points. So extend it like this, then it becomes very clear that, oh, this entire circuit is in parallel with this 2 ohm resistor. And some people forgot that this 2 ohm cannot be, should not be used because it's a balanced Wheatstone's bridge and all that. So that's the answer. Let's get going to the next question. Beautiful question. This is very important question. This kind of questions have come many times. This kind of questions have come many times. Let's do this. Okay. So here it is. There is an electron in hydrogen atom which makes a transition from one state to the other. If the time of the electron in the initial state is 8 times that of the final state, then the possible values of N1 and N2 are. First of all, the question says time period of the electron's revolution. So what is time period? Isn't time period the circumference upon the speed with which the electron moves? What is the circumference of the orbit? Isn't it 2 pi r divided by speed, which is v? Now comes the important memory part. You should know radius is proportional to, alright, so I'll put some constant. It's proportional to n square by z. Yes, you should remember that. And velocity is proportional to z by n. Z by n. So what you are going to see? You will see 2 pi, okay, c1 by c2. This will become z square. N will go on the top. It will become n cube. So what am I going to get? Time period is directly proportional to cube of n. Yes, time period is directly proportional to cube of n. Keep this in mind. Now, once you have got this, just take the ratio of the time periods. Then the possible values t1 by t2 will be n1 cube divided by n2 cube. Now it is clearly mentioned if the time period in the initial state is 8 times the final state, this ratio is 8 by 1. That's what they are claiming. So that means, think about it, n1 by n2, what should it be equal to? Cube root of 8, 2. 2 is to 1. It should be 2 is to 1. So check which of the options has the ratio 2:1. No, this is not 2:1. This is 2:1. Do you see that? So that is the correct answer. Oh, Harsha, you took it like Kepler's third law. Well, okay, cool. But actually Kepler's third law is slightly different. It is square of the time period. Alright, so be careful. Yes. So T is not proportional to n cube in Kepler's law. T square is proportional to r cube. Yes. So be careful about that. Okay. Cool. So that's the answer. Let's get moving. I hope you guys are learning a lot, and if you guys are learning a lot, I hope you have already hit the like button out there to support me, to show your love. Yes, keep it coming, and if anything is there you want to ask me, do not forget you can always post it in the comment section below after the video is over, because if you have noticed, I respond to almost all the comments which you guys post in the recent videos that has been conducted. So go ahead, do that. Okay, so B is the option. Now let's go ahead to the next one. Now this is a very tricky question. Many people do not get this, and many people give the wrong answer. No problem SL. You can always go back, watch the replay as well. Yes, you can slide back. Now let's see how to solve this question. There's a planet which revolves around the sun, elliptical orbit. The major axis length is given. Alright, the semi-major axis length is given, and that is 2 × 10⁻12. Semi-major, that's half the length. The aerial velocity is given. The least distance is also given. What is the minimum speed of the planet in kilometers per second? Okay, let's solve this. Now, what and all do we know? Let's first mark it out. That's very important. So the first things that we know, I feel we know this distance. This distance is how much? The nearest distance is 4.4. All right. No, sorry, that's the aerial velocity. My bad. Yeah, the least distance is 1.8. 1.8 into 10⁻12 meters. That's the least distance from the sun. They have also given the semi-major length. Semi-major length means right from, think about it, here, okay, to here. This length they have given, and that length is given to be 2 into 10⁻12. So if this is 2 into 10⁻12, this whole length, how much will it be? It will be 4 into 10⁻12. Now if this whole length is 4 into 10⁻12, then think the distance from the sun to this point will be 4 minus 1.8. I hope that makes sense. So that is going to be nothing but 2.2 into 10⁻12 meters. You will need all of this. I'll tell you why. When you are closest, your speed will be maximum. Your speed will be maximum at the closest distance, and your speed will be minimum when you are really far in an elliptical orbit. Keep this in mind. Very good. I'll come to that aerial velocity, Sam. And in case you have missed, some of you have missed the gravitation lecture which I conducted, please check out the playlist of electrostatics and gravity. There I have discussed Kepler's 3 laws in detail. Please watch it. Yes, it's very important if you have missed any of the topics. But now the question is minimum speed. So for minimum speed, I need to know this distance, guys. Now talking about aerial velocity. What the hell is this aerial velocity? Aerial velocity is how much area do you cover per unit time? How much area do you cover per unit time? This area that you cover is called as area which you cover per second is called as the aerial velocity. Keep this in mind. This area which you cover. Is this now clear? Now this formula for aerial velocity, dA by dt. Alright, this dA by dt is nothing but that aerial velocity. If this is clear, cool. Now this aerial velocity, I don't know whether you know this formula. This formula is half distance square into d theta by dt. What is d theta by dt? That is nothing but angular speed of that planet. So rate at which the angle changes, that's angular speed, into r square by do. If you do not know this formula, now write it down in your notes in your formula book. Very important formula. Next up, this velocity this velocity will be that omega, basically this d theta by dt, which is nothing but omega, all right, into r. R is the distance between them. Omega r is the distance between them. So v is nothing but omega into r. So basically d theta by dt into r. So think about it. What is the value of omega? Just do the math mentally. So 2 times dA by dt, 2 times of dA by dt, r square comes below. So r square is here into r. That is the value of velocity. Now one of the r goes away, so you just have 2 divided by r into dA divided by dt. That is your velocity. Now substitute all the values. 2 divided by this r will be this distance. What is that? 2.2 into 10 to the power 12. Okay, multiplied by aerial velocity. What is the aerial velocity given? The aerial velocity is 4.4 into 10 to the power 16. Now do the math, guys. 4.4 divided by 2.2 is 2. 2 2s are 4. That's it. So you will get this as 4 into 10 to the power 4, and that would be meters per second, which is 40 kilometers per second. That's the final answer. Yes. Clear? Is this now understood how to solve this problem? Because the question asked you minimum speed, so you cannot use this distance which was given. You have to first figure out this distance in order to figure out what is the minimum speed, and this formula is very important. There have been questions on this. Shall we go ahead, guys? I hope you guys are learning new formulas, new methods, new tricks for solving the problems. Let's get going. So yeah, that's the answer. 40k, that is 40 kilometers per second. Do not forget, before we go to the next problem, a gentle reminder for all of you, the Eklavya batches are starting very soon for all of you who want to clear JEE Advanced after JEE Mains, and these batches are going to start on 8th March, 19th March, 1st May and 29th May. This is your ultimate and one-stop solution for clearing JEE Advanced, because last year more than 500 students cleared JEE Advanced, yes, through Vedantu. Yes, just in Vedantu more than 500 cleared JEE Advanced, and these batches are absolutely free, but you need to qualify for these batches. The link for qualifying and submitting all your details is there in the description box, or join our Telegram group so that you can get all the details out there. Remember, this will contain a lot of problem solving sessions, live sessions, topic-wise revision, and also you will get special tests and also advanced level problem solving with papers from different kinds of sources. All of this free of cost. So do not forget to enroll yourself, submit your details. The batches are starting. The earlier you start, the better it is. All right. So let's get going with the next question coming up on your screen. Here it is. Okay. So you have a toroid and the radius of the toroid is given. Find the total energy stored in the magnetic field. That is the question. So let's see how do we solve this. Okay. So the final answer, by the way, if you notice, it has this B. Now this B is the magnetic field. Okay. So it does not have a number of turns. It has magnetic field. Small b it has, and capital R also it has. Small b is here and the radius is here. Now what is this radius and what is this radius? Let me clarify that. That capital R is this radius, the radius of the toroid, and the cross section, that means this cross section, all right, this is that cross section. That cross section has a radius of b. It's a small circle, so that has a radius of b. I hope you understand that. Cool. Now if this much is clear, let's do this problem. First of all, see, to find the total energy stored inside a toroid, what do we need? The total energy stored is half inductance into current square. That's the formula you need. So that means I need to find the current and also the inductance. Now think about it. There will be magnetic field. Yeah, there will be magnetic field inside that toroid. There will be magnetic field inside that toroid. So what is the value of that magnetic field? That is something which you should know. It is nothing but mu naught number of turns by the total circumference into the current. This is something which you should know. Okay. Now from this, I also know the value of current. Current is 2 pi RB divided by mu naught into N. So I know the value of current, which I can substitute it over here. Great. Now to find the inductance, this is what we'll do. See, to find inductance, first step is always to find flux. First step is always to find flux. So think, what will be the flux through any cross section over here? If you take any cross section over here, what will be the flux? Well, the flux will be the magnetic field into the area. But if I ask about what is the total flux through all the turns, the total flux through all the turns, that will be into the number of turns as well. Isn't it? Magnetic field into area into number of turns will give me the total flux passing through it. Let's substitute, guys, nothing else. So magnetic field is mu naught N I divided by 2 pi R. Okay. Area, well, the area of cross section, the radius is given to be B. So it will be pi B square into N. So what am I going to get? I am going to get mu naught N square, alright, pi gone. So mu naught N square B square I divided by 2R. Now once I get this total flux, please keep in mind one thing. Whatever is outside of the current, that is actually L. Remember, phi is equal to Li. So whatever gets multiplied by current becomes the inductance. Keep this in mind. That's how you find the inductance. Hello Divya Telugu, welcome. Now, if this much is clear, just substitute the value of L over here. I feel you will get the answer. Let's do this. So U will be equal to half L. L is this one, which is mu naught N square B square by 2R into current square. Current square means this whole square. So that is 2 pi RB divided by mu naught N whole square. So many things are going to get cancelled and you will get the final answer from this. I hope this is clear. So let's see what and all will get cancelled. N square will go. B square will remain. Alright. So 2 square and this 2 square will also go. So let's see what and all will go. N square gone. This 2 will go with this 2 and B square is remaining. One of this mu naught will also go with this mu naught. So I'll just put that mu naught below so that I do not forget. And then you have pi square and you also have this R below. One of them will go with this R. So therefore you will have this R and this B square. That's it. Just check this out. This should be the answer. Good evening Pearl, welcome. Yes. So energy density times volume. Yeah, you can do that. It's one and the same thing. You will get almost the same steps, I feel. Even if you use that volume, okay, and magnetic field, it will be almost similar. It's just that I have detailed it out, Omkar. It will be almost similar. Hello Somi, welcome, join in. So this is the answer. Okay. Alright, very good Omkar, if it is really fast, very good. Alright, so let's get going to the next question. A thin prism of angle 15 degrees made of glass of refractive index so and so. It is combined with other prism and the refractive index is something else. The combination of the prism produces dispersion without deviation. What is the angle of the second prism? So let's see how do we do this. The options are 5, 7, 12 and 10. Now what we can do is that it's mentioned in the problem really clearly that there is no deviation. So whatever is not happening, just think about that. One prism deviates the ray, the other prism deviates the ray back. So whatever deviation happens in the first prism is countered by the deviation in the next prism. So the total deviation is 0. Correct? So can I say the deviation in the first prism is equal to the deviation in the second prism magnitude wise? Now if the deviation is same, then think about it magnitude wise. What is the formula for deviation? It is the angle of the prism into refractive index minus 1. The same thing is applicable for the next prism, mu2 minus 1. So it's not really difficult now. Think about it. A1, what is A1? The angle of the prism is 15 degrees. Okay. And mu1 is 1.5 minus 1 is equal to second angle, I do not know, and second refractive index 1.75 minus 1. So this will become 15 degrees multiplied by 1.5 minus 1 is half is equal to A2, and 1.75 minus 1 is 0.75, which is nothing but 3/4. This will go like that. So 15 2s are 30. 30 divided by 3, 10. So the final answer is 10 degrees. I hope this is clear now. Is that understood? So you can solve problems of dispersion without deviation or deviation without dispersion. All these things in a very simple manner. You should just know what to use when. That's it. Let's get going to the next question. All the minions ready for the next question? Okay. Very good, Pearl. All right. Now, next question. Now, next question is very tricky. A lot of people make a lot of mistakes over here. The question is, the current is some sine and cos function of time. You have to find the RMS value of the total current. Options are given. A lot of people use some weird formulas and they get some weird answers, but do not do that. Let's see how do we do this. Okay, some of you are saying already A, I'm not sure. Let's see how to do this. Well, see, what is the definition of RMS? The definition of RMS is, alright, value 1 plus value 1 square plus value 2 square, like that, divided by total number of values, this whole thing under the root. Correct? Now this is when you have separate values. But when you have functions, you do not write it like this. That time the RMS value is the root of, instead of summation you have integration. So integration of that current or whatever that value square, alright, with time divided by the total time. That's it, for one time period. This is how the formula gets modified for a function. Keep this in mind. Hello Satram Murli, welcome, join in all the new members to this family. So keep this in mind. For discrete values, use this formula. But when you have a function, integrate it over one time period or one cycle and use this formula to get the answer. So let's use this and see what will it look like. Okay, so the value of the RMS current whole square, I'll just remove the square root by squaring both sides, that looks simpler then, is integral 0 to t, the whole square of this, that is I1 cos omega t plus I2 sine of omega t whole square dt, the whole thing divided by time period. So this is what I'll get using this formula. I'll just remove this now because I don't need it anymore. Now you might think this integration is crazy. Trust me, it is not. You will see why. Hello Hemant, welcome. Okay, now let's see why this integration is not so crazy after all. Okay, now let's actually square it and see how many terms we get. First term will be it will be I1 square cos square omega t. Alright, I1 square cos square omega t from 0 to t divided by time. That's the first term that I'm going to get. Plus, and first thing, I1 is a constant, so in fact I can take it outside the integral. So this is going to be equal to I1 square integral 0 to t. That's the first term that I'm going to get. Plus the next term, a plus b whole square is a square plus b square plus 2ab. So b square will be I2 square, okay, integral 0 to t sine square omega t dt, again divided by time, plus the last term, all right, AB, 2AB, so 2I1, all right, I2 divided by t, of course, and integral of sine omega t cos omega t dt, again from 0 to t. Now you might think, Sadram, I just took your name, Murli, all right, welcome, join in. Now, you might think that this is very difficult, but trust me, it is not. Now, there are some things that you should know. Please keep in mind, when you integrate cos square for one cycle, the value is always half, which is also the value of one cycle's integration for sine square. Keep this in mind. This is something which you should remember. And I'm pretty sure you would have done this in maths as well. So the thing is, this value, just substitute it as actually, okay, over one time period, this entire value for one time period, actually speaking, all right, sorry, I missed that t over there, all right, sorry, divided by that time period. So the value of the entire integration over one time period, that's why I put one cycle per cycle, is exactly half. So this whole value is basically half, and this whole value is also half. So it will be I2 square into half. Now the only thing remaining is this part. Now let me tell you what, the last part is very simple, because this will be I1 I2 divided by t. Take that 2 inside, it will become sine of 2 omega t dt. Now think about this, guys. This is a sine function. Now when you have a sine function, it will go up and down. For one cycle, what is the average value? Because it will be positive as well as negative. Don't you see the total area will be 0? Don't you see the total area will be 0? I hope this is clear. Yes, is that clear, guys? The total area will be 0. That's the most trickiest part over here. So don't have to worry about that integration. That just goes away, and you just have these two terms out here, and that is equal to the IRMS square. So therefore, what is IRMS then? It will be the root of I1 square plus I2 square divided by 2. That's the answer. Correct? So looks difficult, but it is not. Yes, it can be a difficult question for mains on the higher side. A lot of people will leave this question, but those people who will solve this question, they will definitely get top ranks. Keep this in mind. Correct. So that is the trick to be used. The total area is 0. So that's how it goes away. And the second trick is, remember this. For one cycle, the value of cos square or sine square is half. Keep this in mind. Keep this in mind. Okay, so that's the answer. Very good, very good, very good. Okay, how about this question? How about this question? All right, there is a circular loop which is placed in a magnetic field and it is perpendicular to that field. The loop starts shrinking at some rate. What is the induced EMF in the loop? Now this is an integer type of question. Let's see how to do this. Okay, so you have a loop, you have some radius, and the radius is shrinking, and it is also mentioned that there is magnetic field over there, and the question is, what is the EMF developed? So guys, think about it. The EMF is developed when the flux changes. Now why will the flux change in this case? Because the area is changing. Number of field lines passing through that area will change. That's why the flux will change. That's why EMF will be created by Faraday's law of electricity. So EMF magnitude, which is d phi by dt, that phi itself is magnetic field into area. Magnetic field is not changing, so it will in fact come outside, and you will get B times dA by dt. Now what is area? Area is nothing but pi r square. Correct? Now that pi will also come outside, it being a constant. So it will become B pi, alright. Now r square cannot be differentiated with respect to time. You need to use chain rule, be careful. So you will write it like this. Differentiate it with respect to r and multiply it with respect to dr and again with time. You can see anyways dr will get cancelled. So you will still get the same equality. Now this can be differentiated. So this will be b pi, derivative of r square is 2r, alright, 2r into dr by dt. Now once I get this, it's just a matter of substitution. It's just a matter of substitution. Just think about it. What is the value of EMF? B, what is B? Yes, 0.04, 0.04 Teslas. Pi is just pi, alright, into, just remove this diagram, no longer needed, 2 times of r, into 2 times of r, radius is 2 centimeter, that is 2 into 10 to the power minus 2, okay, and then into dr by dt, the rate at which it is shrinking is 2 millimeters per second, rate of shrinking is 2 millimeters per second, so 2 into 10 to the power minus 3. That's it guys, you'll get the answer. 4 2s are 8, 8 2s are 16, 16 2s are 32, so 32 pi into 10 to the power minus 2, 10 to the power minus 2, 10 to the power minus 3, 10 to the power minus 7 volts, which is 3.2 pi microvolt. That is the answer. I hope this is clear. Very good, Dr. Hatim Ali. Excellent. Hi, Sidhu. Yes. Is that clear, guys, now? Very good. Very good. Very good. Narla, it doesn't matter whether it is HC Verma question, previous year question, Cengage question, that question. See, you are not here to point out that this is this question. You are here to learn. So learn from all these questions. It's very important. Yes. Cool. Let's get going ahead. Very good, guys. Keep learning like this only. Excelente. Now, this is the last question which I have planned for all of you, but this is one of the best question. I'll tell you why. You are going to learn a theorem which most of you might have forgotten or might not have studied. This is going to be such a lifesaver. If this comes, you will see why I'm saying so. There is a Plano-convex lens, diameter 5 centimeter, thickness at the center 0.25 centimeter, speed of light given. What is the focal length? They have asked what is the focal length of the Plano-convex lens. Guys, in lens maker formula, what and all terms are there? Try to recollect. Okay, to find the focal length, let's see what and all we need. 1 by f is equal to mu minus 1. Alright, 1 by r1 minus 1 by r2. Acha, do I know mu? No, but I can find it out. How? Speed of light is given. So let's use that. How do we use this? Remember, speed of light in any medium, which is 2 into 10 to the power 8, is speed of light in vacuum, divided by the refractive index. So therefore, refractive index is 3 by 2. So we got this. Now the only problem is radius of curvature. That is what is important. Very good, Narla, very good. Chalo, focus guys. All right. Now the radius of curvature is this radius. This surface that you see, that Plano-convex lens, is this radius of curvature which I'll need. Okay, how do I find that out? You might be like, sir, the diameter is given. Nah, the diameter which is given, all right, that 5 centimeter, that is this diameter, guys, this whole thing. Yes, this diameter is given. Please understand that. So they have given, this is the Plano-convex lens, they have given this diameter. Keep this in mind. So what will you do? Let's see what we can do. First of all, the radius will be 2.5 centimeter. This will be also 2.5 centimeter. Next thing, the thickness at the center, that means this length. Yes, they have also given you this length, guys, if you realize it. And that length is basically 0.25 centimeter. That is also given to you. Now let me mark some points. That is very important. And let me also draw an imaginary circle. So this will be the imaginary circle, guys. Just imagine this imaginary circle. All right. And let me just draw this. This is the center. For example, this is, let's say this is point A. This is point B. This is point D. Okay, this is point D. This is point E. And this is point F. Okay, till here everybody is clear? Okay. Sadram Uli, please give some model papers to prepare the exam. Sadram, we are doing exactly the same. And if you want more model papers, Sadram, in the link there is a link for the test series. Please join the test series. There will be 20 test series, full test series with discussion. Please join that. Use that. It's there in the description box. Yes, Rajput, definitely it can come. Why not? Why not? That's why it's in the most expected thing. And these kind of things have come in the examination in different forms. Now, the thing is, I know this length, but I do not know this length. How do I find that out? I'll give you a brilliant formula. And what is that formula? Whenever you have a circle and a chord, who is the chord? EF. For that circle, the chord is who? It is EF. Keep this in mind. Okay. Then there is a very simple rule which says the product of EB, which is, if this is the diameter, this AD is the diameter. So wherever they intersect, that is the point of intersection. So this EB into BF, this EB into BF, keep this in mind, is this AB from A to B, okay, this A to B multiplied by BD. Yes, multiplied by BD. This is very important theorem. Yes, very important. And that's it. That will help you guys. I'll tell you how. What is EB and BF? EB and BF both are 2.5 centimeters each. So it will be 2.5 multiplied by 2.5. I hope this is clear. What is A to B? Acha. For that, think this way. Whole A to D, alright, whole A to D is twice the radius, R plus R. So A to B will be radius minus 0.25, sorry, diameter minus 0.25, radius plus radius minus 0.25. So can I say it is 2R minus 0.25 guys, multiplied by BD. What is BD? It is already given to be 0.25 centimeters. That's it. Correct. That means there is only one variable unknown, and that is R. Solving this, you will get the value of R guys. And the value of R that you get is around 12.625 centimeters or something. Yes, you will get it as 12.625. That's what you get. Now you just have to substitute it in this formula. So going back, 1 by F will be equal to 3 by 2 minus 1. Be careful now, what will be R1? Radius of curvature of the first surface, that's a flat surface, it's infinity. So 1 by infinity minus radius of curvature of the second surface, that is negative. Why? Because the center is on the left side. So the radius of curvature will be negative guys. So minus 12.625, and that's it. Solve this because 1 by infinity guys is 0, right? 1 by infinity, 1 by a very large number is 0. You will get the focal length to be, yes, 20, I think you will get it as 25.25 centimeters. Correct. Is that now clear? Yes, that's why it is called geometrical optics. What is the name of the chapter? Geometrical optics. So what you should be strong at? Geometry. Obviously. You should be very good with trigonometry, theorems of circle, theorems of triangle, theorems of quadrilateral, angle theorem, whatever. Everything you should be clear. Yes. So if you know it, that's it. You can solve the problem so easily, else you will be just stuck. Pythagoras, trigonometry, crazy things will apply and you will never get it. So guys, that's why attend all these sessions and you will remember me when you get these kind of problems in the final examination, and you will be like, yes, we attended Shreyas sir's classes. That's why we are able to do it. So guys, others will take long time. Just because you have attended my classes, I am telling you, you will be at an edge. And if you want to be at an edge, then do attend my classes. That's all. Now, do not forget the test series are also there. Some of you are asking, sir, what about test series? You want more tests? Guys, check out the description link. The test series will have 20 tests, full syllabus, 10 before Feb and 10 after the Feb attempt. And all of this usually is at 2,500. But today we are giving it to you for 1,999. That's hardly 100 rupees per test. Guys, I think it's a very cheap offer that you are getting because it's not just tests. You get test analysis plus test discussion plus doubts on the test. Live, everything live. Yes. So go ahead. Do not miss this chance. I really want you to score well. Please join the test series so that we can complement whatever you are learning on YouTube along with this test series. and all really good teachers are going to teach you there. And if you want additional guidance, if you want continuous doubt solving even after the class, and you want all the topics of 11th and 12th also to be revised, if you want that, then don't worry, we have an offer for that too. And we have the regular crash course, which is 10,000 rupees, but you can get 2,000 rupees off if you use the coupon code SHCC again. So this is a regular crash course with the test series, along with more doubts solving continuous from morning till night. And also you will get, yes, keep this in mind, you'll also get other additional sessions for the complete revision of 11th and 12th. So do check it out. Again, all the things are there in the description box below. I hope you have loved it, today's video. And Narla, there are two kinds of batches. One is English, one is Hindi. So if you are wondering, sir, if I join, will it be in Hindi? No, there is a separate option for English and for Hindi. So guys, why should you wait? I think you should join today only. Yes, Rishabh Kumar, you will qualify JEE. Definitely. Why not? Why not? Yes. All right. Chalo guys. Bye bye. See you tomorrow. Again, very special session for 11th standard related topics. Today we have done only 12 standard topics. Tomorrow 11 standard topics. Do not forget to hit the subscribe button and do not forget to smash that like button out there. Bye bye. This was Shreyas here, your master teacher for physics, going live. Bye bye. Take care. Good night.